All right. Hello, everyone. It's day 8 of exponential functions. And today we are going to look at how to solve an exponential function where the exponent is the unknown. So we're going to need to figure out how to undo exponential equations in order to solve them. You're going to learn about a new function called a logarithm right here. And that's what you need to use to find the solution to an exponential equation. And then we're going to write some equations and solve them. So you're going to need your calculator. So if you don't have your calculator available, you might pause this and go get it. And now we'll continue on. All right, so here's an example of how do we solve this. So if we're going to do 5 to the x equals 1,000, well, you know from solving equations before, if that was a subtraction problem, we would use addition to solve it. If it was multiplication, we would use division to solve it. But since the x is in the exponent, the only way to do it right now is to use trial and error. So if you go through your powers of 5, we'll do 5 to the third. You can do this in your calculators, 125. 5 to the fourth is 625, so we're getting closer to 1,000. 5 to the fifth is 3,125, so it quickly jumps from 625 to 3,125. So we know that 5 to some power between 4 and 5 has to equal close to 1,000, but we're not going to get exact. So you could use your calculator and do 5 to the 4.1. And that is about 734-ish. You could go 5 to the 4.2, which is about 862-ish. So we're getting closer to 1,000. And then we go 5 to the 4.3, which jumps to 1012. So somewhere between 4.2 and 4.3 is a number that's going to get us close to the power that we need to take 5 to in order to get 1,000. So we need a more efficient way to solve this. So how do we solve 5 to the x equals 1,000? Well, you're going to learn about a function called a logarithm. So this is exponential. And the inverse of that exponential function is a logarithm, just like addition and subtraction are inverses, multiplication and division. So we can go back and forth from exponentials and logarithms and solve each one of them simultaneously using the other function. Okay, so you're used to the form of an exponential function. The b is called the base, the e is called the exponent, and n is the number. So in this case, 9 is the base, x is the exponent, and 27 is the number. So over here, we can use a logarithm and undo the pieces of that puzzle. So in order to undo a exponential, we use a log. So log base, so remember over here, b was the base of that. Over here, b is called the base of the logarithm. The number goes here, and then the exponent goes on the other side of the equal sign. So this is the base, this is the number, and this is the exponent. So if we want to take this and write it as a logarithm, it's log base 9, and it's a little subscript under there. of the number 27 equals x. So that's how you undo an exponential function. Over here, if you want to take the logarithm and change it back to exponential, your base is 2, your exponent is x, and the number is 8. So it's called do undo. So these two things are simultaneously the same idea. They're just inverses of each other. So basically that's what we do to solve a logarithm, or solve an exponential. All right, so have your calculators ready. How do we use logs? We're going to use them to solve for the exponent. Okay, so we have $1,000. It pays 12%, compounded annually. How many years does it take to get to 3,000? So we should be used to writing these by now. So I have 1,000 times 1 plus the percent as a decimal to some power x, and I want it to equal 3,000. Okay, so we can solve these using algebra now. We're going to divide both sides by 1,000. So I get 1.12, my parentheses, to the power of x equals 3. Okay, so before what we did was we graphed it. Remember we did y sub 1 is 1.12 to the x power. We did y sub 2 is 3, and we looked for the intersection. Well, now we can use algebra to solve it. So I'm going to change this to a log. So remember it's log the base 1.12. The number goes here, so the 3 goes there, and the x goes on the other side. So we can now put this in our calculator and figure out what x is. All right, so I'm going to show you two different ways to do this. If you have a TI-84, okay, so whatever you have there, clear everything out. If you have a TI-84, if you look on the left side of your calculator, the fourth one from the bottom, it says log. Okay, so that logarithm key is log base 10. It's called the common log, and it's base 10 because it corresponds with the decimal system. So if we need to do a different base for the TI-84s, you need to press your alpha key, and up here above window it says F2, and number 5 says log base. Then it sets it up for you, and we can just put in our logarithm. So we have log base 1.12, arrow over to the number part, and that's actually called the argument of the logarithm. So we're going to put a 3 there, and we're just going to press enter. And we get our answer at about 9.69 years. If you have a TI-83, you have to do this differently. You have to do it using the change of base formula. The TI-83s don't have that fancy alpha key. So the way you do that is you do the log of the number. So press your log key and put in your 3. Close your parentheses, divided by the log of the base. So log again, 1.12. Got to make sure you close those parentheses and you get the exact same answer. So that right there is called change of base, because you're changing it from base 1.12 to base 10, or the common log. All right, so putting this in our calculator, we got x is about 9.69 years. That was your TI-84. And TI-83, you have to do the log of the big number over the log of the small number. Make sure you close those parentheses, and you should get the same answer. All right, so we did these exponential situations a while back, and when we wrote out the equations and solved them, we graphed them. We did our y sub 1, y sub 2, we reset our windows and looked for the intersections. So now that we know how to use logarithms, we can do this a little bit differently. Okay, so these are the exact same problems that we did before. So you can read it quickly, but this is where Kyra saved, she's depositing $1,000. To give myself a little more room here. $1,000 into the bank. She's earning 10% interest, so that's 1.10 to some power, and we want it to equal $5,000. Okay, so this is annual rate of interest, so we're not compounding any, we're just doing it once a year. So to solve this, we have to isolate that exponential part, so divide by 1,000. We're left with 1.10 to the power of x equals 5. Once we get that exponential piece isolated, we can change to a logarithm. So log base 1.1 of 5 equals x. So we'll go to our calculator and solve that in a minute. Remember, if you have the TI-83, it's log 5 over log 1.1. Even with your TI-84s, you can do it this way too. But that key is pretty handy, that alpha F2. So we're going to press alpha F2, number 5, log base. We're going to put 1.1 there, arrow over, and we have a 5 there, I believe. Press enter, and it's the exact same answer as we got before when we graphed it. So about 16.9 years to get $5,000. All right, so this is the one about the computer, and it's decreasing by 40% each year. So remember, if it's decreasing, you got to do 1 minus 0.4, which means you have 60% left. So 2100 times 0.6 to some power, and I want to know when it equals 300. So divide by 2100. You can leave it 300 over 2100 if you want, or you can reduce it to 1/7. 300 over 2100 is 1/7, and then I can change to a logarithm. So log base 0.6 of 1 divided by 7 equals x. So calculator, log alpha F2, number 5. So log base 0.6 of, where am I? 1/7, so 1 divided by 7. Oops, I got too many parentheses here. Equals, enter, about 3.8 years. If you're doing it with your 83 or even with your 84, press your log key, 1 divided by 7, close your parentheses, divided by log 0.6, close your parentheses, enter. So you get the exact same answer. $3.8 years. All right, so this is the one you can go back. This is the one where we just plugged in 15 years. We didn't need to graph it. All we had to do was solve it. So you're not going to need a logarithm to do this one. So 0.018 for your interest, add that to 1 to the 15th power. So we just put that in our calculator before. And we got 248,296 and 31 cents. Okay, so no logarithm needed. We weren't solving for the exponent. All right. May as well go ahead and do this last one. So this one you're borrowing 325, 4% interest, so 0.04 to some power equals 1,000. Okay, so the nice thing about these calculators is you can use big numbers. You don't have to estimate them as decimals, because then your answers are more exact. It's kind of like sig figs in chemistry. So if I divide by 325, I get 1.04 to the power of x equals 1,000 over 325. Just leave it just like that. Now I need to change to a logarithm. So log base 1.04. And I'm going to put this in parentheses since it's a fraction, equals x. So you can go to your calculator again. Alpha F2, number 5. So I had log base 1.04, arrow over 1,000 divided by 325. Parentheses are already closed, so press enter and you get 28.7 years. With the TI-83, without that fancy key, you press your log key, LOG, 1,000 divided by 325, divided by, make sure you close those parentheses, logarithm again, 1.04. Close your parentheses, press enter, you get the exact same answer. All right, so we will actually do a whole nother unit of logarithms before the EOC in the spring or in the fall. Yes, you have to take the EOC in December. So logarithms are on the EOC, and we will definitely do another unit on logarithms before we do that. All right, so I believe we came out with 28.7 years on that one. All right, a little bit more logarithms tomorrow, and then we are done with this unit.